What we're going to talk about today for a short period is relative age dating. You're kind of thinking, relative age dating, is that like dating your uncles or your aunts? No. It's not about dating your relatives. It's about finding out what the relative age of things are. Anybody tell me what they might think that might mean? What is relative age? Christine.
I know that I'm probably younger than Kim, but probably older than Jim.
Perfect answer. It's your age or the age of an item in relation to something else. And what we're going to do is we're going to talk about relative age dating of rocks. Many of you have probably been to this place. Do you know where it is? Where? Anybody? It's the Grand Canyon. Have you been there? Beautiful place, isn't it? You've seen pictures of it though, I'm sure. And look at all the complicated geology and all the layers of rocks. Through the technique that I'm going to show you here and the principles we're going to talk about, some of which we've talked about already, you're going to learn and know how to unravel the geologic history of something as complicated as this. So there's a little bit of use to this, and we'll come back to this for the very last slide we look at. So we'll start out with KWL that you've seen before. What we know already are the basic principles, and we'll talk about those. I'm going to review those real briefly in a moment. What we want to know is how to use these principles to determine relative ages, and from that, a geologic history of specific rock units. Okay? And the geologic history is going to be a general history. What happened first, what happened second, what happened third, what happened fourth. Pretty simple. Okay, two of the basic principles that we need to review are the principles of superposition and original horizontality. So can anybody think of what superposition might mean? It's a fancy word for meaning what's on top. Okay, and how about original horizontality? Original, it started out flat. That's all those words mean. That's what the principles are called. Superposition means that the oldest stuff is on the bottom and the youngest is on the top. That makes good sense, doesn't it? The oldest stuff, layers were laid down, generally in the ocean, and then other layers laid on top, and other layers laid on top, and other layers laid on top. So the stuff that's on top is usually the youngest. That's pretty basic and pretty simple, isn't it? The original horizontality basically says that most all rock units are laid down flat, or pretty flat. So if you got a rock unit that's not flat, like this one here, that seems to be not flat, what can you imply happened to it? If it was laid down flat, and now it's not flat, what happened?
It was bent.
Something happened to it, got bent, got folded. An event happened, okay? Something physical happened to those rocks. If they started out flat, and now they're folded, something happened. An event that we're going to be interested in, that's going to be part of our geologic history. So, geologic history of this unit here, this strata here, A got laid down, then B, then C, then D. Could it get any simpler than that? What happened with this assemblage right here? What happened first? Anybody?
A was laid down.
A was laid down,
B was laid down.
then B,
Then C.
then C, then D, then what?
Folded.
Then it got folded. You see that? And then what happened?
E got laid down.
Then E, then F. That's all we're getting at with original horizontality and superposition. Isn't that cool? Now, the next principle, the last principle we'll talk about, one we've reviewed before, is the principle of cross-cutting relations. What this means is that features, things that happen, are always younger than the rocks they cut through. So this here is what's called, this is an intrusion of igneous rocks, molten lava, magma from somewhere, got intruded in a dike and then into a sill, but the common sense solution here says, what's older here? The rocks that already existed, or these rocks that got pushed through? The rocks that are already there. And that's all we're saying, is that this feature that pushed through these other rocks happened later. They're younger. Okay? That makes good sense, doesn't it? All right, so what we're going to do now is I'm going to talk you through an exercise, and then you're going to get into teams of 3, and you're going to do an exercise on your own with a little bit of help from me. Okay, so this is pretty complicated. Look, it's a little more complicated than anything we've looked at before. Shh, it's okay. Thanks, guys. And what I want you to figure out with this is what's the youngest to the oldest, and a little bit about the geologic history. So, when you look at this, Do you see these lines here? Anyone know what those are called? Faults. Those are earthquake faults. Can you visualize in your mind this unit E looks the same as the unit A, right? It's the same kind of rock. By the way, this is the symbol for limestone, these brick-like symbols. So what happened here was A and E used to be lined up. And H and H used to be lined up. And what happened? They got moved. The fault happened and the rock units got shoved in relation to each other. So, can anybody guess what happened first in this assemblage? G. G was laid down. And then what?
C.
C. And then what?
A.
A. Actually, E refers to, I told you a little bit wrong there, E refers to this fault. So A was next. Then what?
Then fault B.
Well, fault B, though, cuts C. It moved C. It moved A. Did it affect F?
Could.
It does affect F.
Okay.
Okay? It affected F because it cuts right through F, right here. So, G, C, A, then F, then fault B.
B. Okay.
Then what?
H.
H, exactly, very good. H got laid down. Then what?
D.
D, and then what?
I.
I, and then what?
E.
Fault E. A plus. See how simple it is? Now, when you write your geologic history, what you would say is something like, Unit G was laid down, and as we learn more about what these rock symbols mean, you might be able to say something about the environment or what happened. Unit G is a sandstone unit that was laid down, and then C is a siltstone, and then Unit A was laid down, a limestone, then Unit F, another sandstone, and then a fault happened B. So that's how you would write the geologic history as a narrative, as actual sentences. Okay? Does anyone have any questions? Okay. What I'm going to do is pass out an age dating exercise, and you're going to get in groups of 3. We got about 6 or 7 minutes to work on this, and you, group of 3 here and group of 3 there, work together on it, if you would, and come up with a youngest to oldest, and a little bit of a couple of sentences of geologic history. So what do you think, Steve?
Oh.
So it would be then.
That looks like that might be with the protrusion or obstruction.
It's an intrusion. C is an intrusion. See how it cuts across the other units? If it affects the other units, it has to have happened after that, right?
But I don't, it depends on that.
So it'd be D's here. Okay?
Yeah, that's gonna be
So
B.
maybe that came back and then it got bent, or it got bent.
No, it got bent.
Well,
And
isn't that
then,
what-
otherwise, this would be.
Okay. Isn't that what this little point is? So there was some, yeah.
What do you think's the oldest?
D.
So why do you think this?
Oh, I'm sorry.
Oh.
That's why we put it in.
We all fell asleep.
Very good.
Yeah, we know.
Or.
And then, do we need to indicate that
They
they
cut it.
Yeah, well, not in the rock units, that would be in your geologic history, so you might do,
Like a
well, she's
little.
starting exactly right there, you put a little arrow and say old.
Okay.